In this video, we're going to take a look at graphing absolute value functions. So to start talking about graphing absolute value functions, we need to first talk about what we call the parent function for absolute value. The parent function is this basic formula with no numbers that are extra. Y equals the absolute value of x is our parent function. Notice it starts at the origin and it goes up by one box on the right and the same thing on the left. It has a positive slope. It has an like an even shaped V on both sides, creating this graph that's our parent function. Okay, so let's take a look at what could change about this parent function to create multiple versions of this. Infinitely many versions. So we have standard form of an absolute value function. F of x equals a times the absolute value of x minus h plus k. We have a vertex with absolute value functions. So notice here would be what we call the vertex of our function, the center. And our vertex, when we pick it out of our standard form, is simply hk. So that is our vertex. Very important piece of information. And then let's talk about the other transformations that happen. So I've created a picture of standard form down here, and I've added in one more letter. This b in front of x we'll talk about in just a minute. So first let's discuss the a in the front. The a helps us with two things. If a is positive, it makes our graph open up, which is our orientation of our graph. And if it's a negative a, it will open down. That V will be facing downwards. But A also has another job. We say that it is our vertical stretch or compression. Whoa, let me spell vertical correctly. So vertical stretch is when A is greater than 1. And it's a vertical shrink or compression when A is between 0 and 1. So like when it would be 1/2, for example. So if A is greater than 0 but less than 1, it's a vertical compression. Now, let's talk about this vertex and how that works. So H is when it shifts left or right. So you might have seen stuff like this before, but if not, we'll review it right now. So if you have a minus and then this number here, so if it's minus h, the graph's going to move to the right by h units. And if it says plus h, it's going to go to the left that amount. So we'll say h units again. So it's left or right, and if it's a minus, it is to the right. And if it is a plus, it is to the left. So it's kind of opposite of what we think. This k is our up or down shift. So if k is positive k back there, it's going to go up by k units. And if k is negative, it's going to go down by k units. Like whatever that number would be. So then we go back to this b over here. So b is our horizontal stretch or compression. So let's write that up here at the top. It's a horizontal stretch. Now the tricky part is it's going to be a horizontal stretch if b is greater than 1, but we say it's by a factor of 1 over b. So if that was 5, for example, we'd say that it's horizontally stretched, but by a factor of 1/5. And then it's going to be a horizontal compression if b is between 0 and 1, and it's still by a factor of 1 over b. So if that's 1/5, for example, for our b, it would have a horizontal compression by a factor of 5. So it kind of works in an opposite way of the vertical stretch. So let's take a look at some examples of what we might be asked about this. So if we were to be asked to describe the transformations of the following, we have this absolute value of x minus 4 in example 1. The minus 4 is just related to our h. So minus 4 means it's going to go to the right 4 units. Number 2 has the plus 2 on the inside of the absolute value and then minus 1 out back. So that's our h and our k. So h being positive 2 makes it shift to the left 2. And k is negative 1. So that would go down 1 unit. Now, let's look at number 3. We have a negative in the front, the absolute value of x, and then plus 5 in the back. So it's not in the absolute value symbol. This negative out front makes our graph open down. And we also say this is a reflection over the x-axis. So it reflects over the x-axis is the best way to say that, more formal. And then the plus 5 out back there makes it go up 5. So it does 2 things. In number 4, we have 3 extra numbers on our parent function. So they've been added in. They're different than our basic parent function. So the 1/2 is a vertical compression. I'm going to abbreviate a little bit. It's a vertical compression, and we say by a factor of just that number. So there's nothing fancy when we write the factor. Vertical compression by a factor of 1/2. And then the 1 on the inside of our absolute value symbol makes this shift to the left 1. And then the negative 6 or minus 6 out there in the back makes our graph go down 6 units. Okay, so let's take a look at a few more. In these examples, they want us to write the absolute value equation given the following information. So if it translates up 4 in number 5, we could write y equals, and then we have the absolute value of x, and then it just went up 4. So that goes out behind the absolute value symbol. Remember, that goes with our k right over here in the back. So let's look at another one. Number 6 says shifts to the right 7 and reflects to the x-axis. So right 7 is inside the absolute value symbol, and right means it's minus 7. And reflects over the x-axis means we need a negative in the front right there, because it makes it open down. Translates left 3 and down 1. So left 3 needs to be inside the absolute value symbol, and left we represent with plus 3, and then down 1 needs to go out behind the absolute value symbol, where the k would have been. Number 8 says that it has a vertex of negative 2, 3, and vertically stretches by a factor of 5. So the vertical stretch goes right out front. The vertex of negative 2, 3 is a little tricky, because the vertex, if we had picked it out as negative 2, 3, but remember our standard form is a times x minus h plus k. I'm just going to write it down here for a second. Minus h is part of our standard form. So if we needed to pick out that h equals negative 2, this actually has to be x plus 2 in order to pick out that h is negative 2. And we'll work more on that in class. And then the 3 just stays the same. So the moral of this story here is that when you have a vertex, you got to change the sign of the h when you put it back into your equation, and you want to write the equation. All right, so let me just write right here. H was negative 2, and your k was 3, because our vertex is always hk. Okay, let's do 2 more. Reflects over the x-axis and shifts down 11. So reflects over the x-axis would be a negative in the front, and shifts down 11 means it's not inside the absolute value symbol, it's out there behind it. Makes it go down 11, so minus 11. And number 10 says translates 8 up and horizontally stretches by a factor of 1/4. So that part, we haven't seen any of those yet, but 8 up. That one's pretty simple. Up 8 just looks like that. But then this horizontal stretch needs to go right there. So let's write it with that number. If it stretches, that means it's a number greater than 1. So that's just 4x is what we need to put right there for that